Good morning, my name is Dustin McCauley. I'm with the local HVAC distributorship Wind Supply here in Central Texas. We're on a project today with Green Builder where we're installing LG equipment. What we'd like to do is go through each piece of equipment and explain what we have here for this project. So starting out with, we have a multi-zone system where we've got one single outdoor unit that is going to be refrigerant piped to a branch controller. This is there for all the refrigerant piping to connect to, and each zone can be controlled independently. So we'll install this in the attic that's connected to the outdoor unit. Then two of these branches will come off to feed the refrigerant piping for each of these indoors. And we have a multi-zone system selected, so what that means is that we can control temperatures independently of one another. But we have two separate machines that do that with refrigerant flowing through each one. So we've chosen a vertical style air handler. It is a traditional style cabinet, which what you would typically see in a residential application, which enables it to retrofit very easily. So we have a traditional cabinet that you're accustomed to seeing in any installation. We have a supply plenum connection. We also have a return plenum connection. It's going to be connected to the bottom. One thing I'd like to note about this is that it is a multi-poise, a multi-position air handler. So it can be installed in any arrangement you need, a horizontal left, a horizontal right, an upflow as you see, or we can even invert it and make it a downflow. So again, it makes it very adaptable for any application. We're also going to be controlling these with the premium wall controller. There's a lot of good features and benefits, scheduling and user functions that come with this controller. We also have an ArcCool wall unit that we're going to be installing. This is a new concept and makes it a nice mirror finish, right? So it just gives it a better aesthetic look to it. It kind of gives a new aspect to having the unit hung on your wall. I mentioned that these were a very conventional air handler. The one thing that's not conventional is the refrigerant piping connection that we have. We're doing this with flare connections versus a sweat connection, which is what you would typically see. So one last feature I'd like to mention about this equipment is the inverter technology that it has. That inverter technology allows that compressor to change its frequency or the amount of refrigerant that flows through the system. It's there to match the demand, where we have what's called a shoulder season. So in the fall or the spring, where there's not quite, the temperature's cold enough for heating and not quite hot enough for full demand cooling, it allows it to match that low demand where there might be a little bit of cooling but not a lot, and allows it to back off on the capacity that it's providing to better match the load and save on energy. Whereas a conventional system will overshoot the demand, so let's say we have it set at 72, we'll overshoot to about 71, and then we'll shut off, we'll shut the compressor off completely, allow it to warm up another degree above set point, so it goes up to 73, and then it will come on and go to 100% to again satisfy that demand one more time. All right, well this technology doesn't have that. It's kind of what of a glide technology where it'll get close to that set point and then the compressor will start backing off just to maintain it until it finally can't back off enough and it does end up overshooting it. That's when it will finally satisfy. Now that seems counterintuitive. Why is that compressor continuing to run? But actually we found if we let that compressor run continuously at a low command or a low demand, that we save on energy. It's that inrush current that we get when it bangs onto that 100% that really consumes the amperage or the kilowatt hours. So this technology is great. It saves the life of the compressor because it's not going from start to stop. It's ramping up and ramping down. It's also saving on energy so that we don't have that inrush current that we would get with a conventional system.